In today's experiment, we are going to use the LED array to explore the electromagnetic spectrum and learn about the properties of light. The electromagnetic spectrum is the full range of all types of electromagnetic radiation. And radiation is simply energy that travels and spreads out as it moves. It also has wavelengths and frequencies. Although all radiation moves at the same speed, all forms of EM radiation have different amounts of energy and as a result have differing wavelengths and frequencies. Frequency is the number of waves per second, so the higher the energy wave, the higher the frequency, or more waves per second. The wavelength is the distance between wave crests and is closely connected to frequency. If we take a closer look at the spectrum, we can see that radio waves have longer wavelengths with lower frequencies when compared to gamma rays, which have shorter wavelengths but higher frequencies. Humans are able to distinguish more colors than most animals, but some animals, such as bees, birds, and certain fish, have a broader range of color that allows them to see ultraviolet light. Butterflies, for example, can emit UV light through their wings as a defense against predators. The wings are coated with scales that allow them to reflect different color spectrums, depending on their shape and the angle of light. They are also thought to have the widest visual range of any animal. On the contrary, the visual light range for humans is very small, between 400 and 700 nanometers, and falls between infrared and ultraviolet on the electromagnetic spectrum. Things like light bulbs, fireflies, and stars all emit light that is visible to humans. Most of the time we experience light as a combination of all the different wavelengths. However, our visual system can detect the different wavelengths of light when those wavelengths have been separated by refraction. The LED array contains 11 differently colored LED lights that can be controlled using the top dial. Each light is labeled with a corresponding color as well as the wavelength of that color. We'll start by facing the array towards a white wall or use a piece of white paper. In order to best visualize the light, turn off all other lights in the room. Turn on the array and you'll see that some parts of the paper show color, but in the middle, the light is white. Using the black electrical tape, experiment with blocking some colors. Place a strip of tape over the colors excluding red and green. As you may have guessed, the resulting color is yellow. Looking at the visual light spectrum, it makes sense that the red and green combination would produce yellow since it is between red and green on the spectrum. This method of creating color is called additive color mixing. So that's going to do it for the LED array experiment. If you enjoyed this video, be sure to subscribe. And if you have an idea for an experiment you'd like to see, let us know in the comments below or on any of our social media platforms. Until next time, have fun learning.